Okay, a common application of mass stoichiometry is called gravimetric analysis. Gravi indicating weight, measuring the mass of things. It's stoichiometry involving masses. So it's a technique used often to calculate the mass of an ionic compound. So you precipitate out one part of that ionic compound, so you turn it into a solid, that enables you to separate it, purify it, dry it and weigh it. And once you've got the mass of that precipitate, you can do some stoichiometry to work out the mass of the chemical that you're trying to find out, the reactant. And that's the process. Now, if we are back in class, we'll be doing a prac on this. If not, we'll just be doing it as theory. So, this is a common sort of problem that you'll get. You've got some commercial product. That commercial product contains an ionic compound, in this case bar flakes containing magnesium chloride. You're wanting to work out how much, so you buy the box of bar flakes in the supermarket, and how much of that box is actually magnesium chloride, or are they just filling it up with other rubbish that doesn't actually help to soothe your aching muscles? Well, this chemical analysis will enable us to work out the purity of our bar flakes. So how much magnesium chloride is in our bar flakes? So we dissolve the bar flakes and then we react. We add an excess of silver nitrate. Now, adding silver nitrate to magnesium chloride is going to produce a silver chloride precipitate. This is a common double replacement reaction to produce a precipitate. Chloride being precipitated out as silver chloride. So once we get that precipitate produced, we can collect it, we can filter the solution to get out the silver chloride, we can wash it, dry it and weigh it, and work out the exact mass of silver chloride produced. So once we know the mass of silver chloride produced, we can then go back and work out the mass of magnesium chloride that must have reacted using stoichiometry. So step number one is, or part A, sorry, is just the basic mass stoichiometry steps like we've just done. Part B is just converting that to a percentage by mass. Now, a key part of these questions is actually working out which mass is which in the question. We're given two masses. We're given the mass of the bar flakes and we're given the mass of the silver chloride precipitate. Now the bar flakes, that mass, we don't actually know what that represents because that's the whole bar flakes. Some of that's magnesium chloride, some of that is other stuff. This is the mass of the whole sample. This is the total sample mass. It's a mixture. Can't use that to work out moles at all. What we can use to work out moles is the mass of silver chloride precipitate. Because it's the mass of the precipitate. We know that precipitate is pure. We know the mass of silver chloride, therefore we can know with good confidence what the number of moles of silver chloride is. So that's what we can do stoichiometry from. So your first step into just working out which mass that we use is the key step in gravimetric analysis. So the precipitate that we're going to do the stoichiometry on, silver chloride, total sample mass, that we're going to use, we're going to do in that final percentage calculation actually. But that's the total sample mass that we can't do stoichiometry on. So getting those two masses straight first up is the key step. So, once we've got that, it's the basic 3 stoichiometry steps. So, moles from the given information, moles of the precipitate, always in mass stoichiometry. So just use the mass formula as we have been to work out the number of moles. Then 1 over got to get moles of the unknown. Now we want the magnesium chloride, which is 1. We've got the silver chloride, which is 2. So it's going to be 1 over got is 1 over 2. To give us the moles of magnesium chloride. And then as before, third step is turning it into a mass to give us the mass of magnesium chloride in that sample of bath flakes. So that's A. The mass of magnesium chloride in the sample is 0.241 grams. B. What percentage of the bath flakes is magnesium chloride? Well, we know how much magnesium chloride, we know how much the whole sample weighed, we just turn that into a percentage. Then on to a question. Now, what's our mass of precipitate? So our mass of precipitate in this case is the 0.3881. So we're going to calculate moles of that. The other mass is the total sample mass. If I can reach that. So we're going to use that to work out the percentage. So when you do that, hopefully you get those answers. I'll just introduce the second one in a similar way. So in this one, the mass of the precipitate that we're going to calculate the moles of is 1.037. So that's what we calculate the moles of. And the other one is going to be to calculate the percentage. So given those hints, have a go at those questions and then I'll run through the solutions.